All right. If you have not done so already, please check into On Campus. Again, that should be like the first thing you do, and people are still waiting until like the last second to do it. So please check in the first thing you do when you get here. Okay, because that's how I'm gonna like answer questions in a review as well. All right. So today, a couple things I want to do. I want to review kind of quickly about what's on your screen. So arithmetic sequences and geometric sequences. I want you to recall factorials because that's going to be very important today. And then after we do that kind of quickly, I want to go over like the most common question on W18. It doesn't pop up until 5 minutes after class. It does. I have it scheduled to pop up like 2 minutes before class starts. So again, that's like the first thing you should be doing when you get in here. All right. Um, and then down in the bottom left hand of your screen, I have just kind of, I guess, a legend for summations and what each piece means. All right. So first, arithmetic sequences. That's kind of the first real thing we did with this chapter. I get that we were kind of doing this stuff before, but the arithmetic sequence is kind of like the first real important thing that we did with this chapter. Okay. And there are two equations for it. There's finding the nth term. So you find the nth term by adding the first term plus n minus 1 times our common difference. Okay, so if you remember an arithmetic sequence, you're just adding some term over and over and over again. And that term is the common difference. In order to sum an arithmetic sequence, a finite arithmetic sequence, or the nth partial sum, okay, you take the number of terms you are adding together, you divide that by 2, and then you multiply that by the first term and add that to the nth term. All right, for geometric sequences, again, we have kind of the same rules. To find the nth term, you multiply the first term times our common ratio to the power of n minus 1. And if you remember, a geometric sequence is a sequence of numbers where you're just multiplying by the same term over and over and over again. Okay, and that same term, that it's called the common ratio. All right, and again, the nth term is the first term times our common ratio to some power. And then we have two equations for sums. We have sums of a finite sequence and sums of an infinite sequence. The sum of the finite sequence is where a sequence just stops at some number. Okay, and to find that, you multiply the first term times 1 minus your common ratio to the power of n over 1 minus your common ratio. And then to get the sum of an infinite sequence, you divide the first term by 1 minus r. Okay, and there are two kind of limitations for both of those. Okay, in this equation for the finite, your common ratio has to be greater than 1. Actually, that's not true. Yeah, ignore what I just said. Your common ratio for this blue term can be anything. For the green one, though, r must be less than 1. Okay, and that green part is what we did this past night and then before for homework. Okay, and then quickly before we get to a question or two, factorials. Okay, factorials, again, it's something we've gone over a couple of times, but it's really going to be important for this class. And if you remember the definition of a factorial, n factorial is 1 times 2 times 3 all the way up until n. Okay, and a more concrete example of that is 5 factorial, which is 1 times 2 times 3 times 4 times 5. Okay, and we're using that same pattern. Okay, So before I get questions on W18, is there anything on the screen so far that doesn't make sense? Okay. So I want to go over one type of question. And a lot of people were asking, what do you do at like 95 on IXL? So let me pull up a problem here. Okay. And this says, does the infinite geometric sequence converge or diverge? All right. And I did mention this a couple of times, probably not as explicitly as I should have. But infinite sequences, especially geometric ones, can converge or diverge. And what that means is that it basically has to do with the common ratio. Okay. So if a common ratio is less than 1, then your geometric sequence converges to some number, right? You can find the sum of this infinite sequence because r is less than 1. Okay, so that's the first part. It has converge or diverge. And it converges if your common ratio is less than 1. Okay, it diverges if it's anything over 1. And then once you press converge for this, it says find the sum, write your answer as an integer or as a fraction in simplest form. Okay, so because our common ratio is less than 1, we can use our equation, plug that into a calculator and simplify, and whatever that number is, that's our answer. Okay, if it diverges, then it just ends there. Okay, so really what those questions past 95 are all about is just, 1, picking out what the common ratio is, 2, interpreting what that means in terms of summations, and then if it requires it, find the sum. Okay, so remember, converge means common ratio is less than 1, diverge means it's much greater than 1. And if you have other questions about that, I'll be on Teams after this lecture, and then we can talk a little bit more about your questions specifically. All right. Also, I haven't actually put them in yet, and I probably won't until probably tomorrow. Part of that is I'm lazy, and part of it is I'm trying to be maybe a little bit more lenient with people getting this work done with remote learning happening. Okay. Um, so, are there questions about that problem? All right, so today we're talking about really what it boils down to is we're talking about combinations. Okay, and this is kind of our first step into real probability. And before we get to all this stuff, I will just want to preface this. A lot of probability is finding a sample space. So it's finding the number of different ways something can happen. All right, and one of the best, or one of the, like, I guess most elementary ways to do that is to find combinations of some event. And that's what we'll be doing. We'll just be finding combinations of things happening, but we're going to introduce it in a little bit different of a way. And I'm following the book on this. Just bear with me in terms of like what that actually means. All right. So we're going to look at this in terms of binomial coefficients. And there's a lot on your screen right now, and it probably looks a lot jumbled up. I'll make this a little bit smaller. Okay, so I want you to think about one, what a binomial actually is, and then two, how you would FOIL that with different powers. Okay, so on the left here, I have a binomial and then a raised to a certain power. Okay, so that first line, x plus y to the 0 power, well, that's just going to be equal to 1. Right? Anything to the 0 power is just 1. X plus y to the first, again, that's just x plus y. X plus y to the second, that's when you would FOIL. And get x squared plus xy plus 2xy plus y squared. Okay, and then x plus y cubed. Again, you would FOIL x plus y with x squared plus x plus 2xy plus y squared, and so on down the line. Okay, and then on this right-hand side, I have what those expansions are actually equal to. Okay, and I have their coefficients in blue because that's going to be important for what we're doing later on. Okay, so I want you to just look at this for a second, and especially their coefficients and their different powers, and just kind of see if you can understand a pattern, and then we'll talk about it here in a second. And while you do that, I'm going to highlight just a couple of things on your screen. All right. So again, I'm hoping that you kind of looked at it and just tried to find a couple patterns here. And the first thing I want you to look at is just the number of terms for each one, right? So in each of these, on the left, just focus on the exponent, okay? So in this first one, that's 0. And then on the right, there's one term. On x plus y to the first, the exponent is 1. On the right, there are 2 terms. X plus y to the second, the exponent is 2. There are 3 terms. X plus y cubed, the exponent is 3. There are 4 terms. Okay, so there's always going to be n plus 1 terms. Right, where n is the exponent. Then I want you to focus on the exponents on the right with all the actual expansions, all right? So the exponents on the right will always increase and decrease, right? So for each of these x values, it starts really high and then counts down to 0. So you can see that probably the most in this x plus y to the fifth, right? X to the fifth, x to the fourth, x cubed, x squared, x to the first. And then really, if we wanted to add an x to the 0 on the right, we could. So they go down for the x's. And then up for y's. And then kind of to go along with that, and this is a good check for what you'll see later on, if you add up any one of these powers, right, you always get the power that we're actually working with. So right, on this term, 4x to the first, y to the third, that 1 plus 3 will always equal 4. And that's true for any power going along, right? So 2 plus 2, that's going to be 4. 3 plus 1, that's going to be 4. If we jump down a line, x to the fourth, y to the first, 4 plus 1 is 5. Move right, 3 plus 2 is 5. The sum of each of those powers is always going to be these on the left. Okay, and we're not, again, this isn't like the most important thing. I'm just trying to get you to see patterns in binomial expansions. Okay, because some of these patterns are very, very important. If you don't understand it 100% right now, that's okay. Again, we'll go over it. But just some things to look at. All right, and then the last thing I want us to look at are the actual coefficients, which I've highlighted in blue. Okay, so in blue, you should notice that the coefficients are kind of repeating themselves. It'll kind of rise up and then it'll go down. Right, so 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10. This 10 should be blue. And then 5 and 1, okay? So again, there are 4 patterns that are very useful. Number of terms is always n plus 1. Exponents for x go up, or sorry, go down. Exponents for y that go down. The sum of the exponents is always going to be equal to n, and then the coefficients will always repeat themselves. Okay, so I realize this is kind of a vague description of what we're doing, but are there any questions over any of those things that we just went over? And then before we move on, if we kind of take those coefficients out and put them by themselves, what's the trick for the middle ones, like the 6 and 10? We'll get there. All right, so we're getting there right now. So if you take those coefficients and put them kind of as is, but without any x's and y's and exponents, we get this triangle. Okay, and you can get each term by summing together the two just above it, right? So 1 plus 1, that's 2. 1 plus 2, that's 3. 2 plus 1, that's 3. 1 plus 3, that's 4. 3 plus 3, that's 6, and so on, right? And these are the coefficients. And this is a quick way, and this continues going on. This is a quick way, or probably the longer way, in order to get coefficients of all these things. And this is called Pascal's triangle. And these follow a pattern, and it's not necessarily just adding the two things above it, okay, which we're going to get into here in a second. But if you ever need to find the coefficients of, like, say, the third binomial expansion, we can just go to this triangle, list them out, and they're right there for us. Okay, and you should notice too that this is the third. If we go up, this is the second. This is the first. And this top one, that's called the 0. Okay, so this, in sums and series over the last couple of classes, we've been dealing with the 0 term, and where our lower limit is 0. This is one of those cases. Okay, so Pascal's triangle is really, really helpful. And I think actually stuff like this does show up on the ACT. If I remember when I took it, there was a question about a binomial expansion of like the third power. So if you know this Pascal's triangle and you kind of know how it works, it's a quick and easy point that you can get right off the bat. And again, this doesn't require a whole lot of math. It's just knowing a pattern of this triangle. Okay. So let's move on just a little bit. To how we actually find coefficients of a binomial expansion. So yes, we can use Pascal's triangle, but say we're trying to find like the 30th expansion and we're trying to find a certain coefficient. Okay, that's not as easy. All right, so coefficients of a binomial expansion, those are called binomial coefficients. In order to find them, we use this theorem, which is on this page, right? So in the expansion, x plus y to the nth power, x plus y to the nth, again, it's going to follow our pattern. It'll be x to the nth power plus n times x to the n minus 1, right? So exponents of x are going to be decreasing. Exponents of y are going to be increasing. And then we're going to have some coefficient. That coefficient will always be NCR. And that's what this boils down to. And NCR, you'll hear me refer to it as N choose R. And in order to find N choose R, you take N factorial over N minus R factorial times R factorial. And that will get you that specific coefficient. Okay, so I'm going to give people another 30 seconds or so to write this down, and then we'll talk about what this actually means and how we use it. So again, one of the most important things that you can get from this is this equation right here, which we should know kind of right at the top of our heads. There is a way to do this on a calculator, which I'll show you later. But for right now, I just want you to know the actual equation. All right. The other thing that we can get from this, which we kind of went over above, is the actual pattern of what an expansion does. Right. So again, exponents of x will decrease, exponents of y will increase, and then we'll have certain coefficients. Those coefficients we can get from this equation or that Pascal's triangle, which I showed you above. Okay, so let's just do some kind of simple calculation type stuff where we just plug in numbers and we get another number. All right. On your left, I have a couple of examples, and this is kind of the first part of your homework. And I'm not actually sure if we're going to get to the second part of your homework just because of time, and I want to keep this kind of short. But I will for sure have you do this, okay? And again, this is just plug and chug type stuff, okay? So on the first example, we have 8 choose 2, right? So we just plug in 8 and 2 into our equation above on the right. So that will be equal to 8 factorial over 8 minus 2 factorial times 2 factorial. So if we simplify that and kind of use what our definitions are, yes, you can do this in a calculator. Again, right now I want you to just actually know the equation, because that's what I would like you to show in the homework. Because again, even though you can do this on a calculator, if you ever go into like legitimate stats, and I don't mean like AP stats next year, I mean like if you go into calc-based stats, knowing this stuff is really important, and it can allow you to do a couple of shortcuts. Okay, so if we rewrite 8 choose 2 by definition and then kind of simplify or expand our factorials, we get what's written above. And again, we can cancel out common terms, and we're left with 7 times 8 over 1 times 2, which is just 2. So we get 56 over 2, which is just equal to 28. Okay, so questions on that example? All right, another way that this can be written is in kind of shorthand notation, and that looks like 10-3. All right, and what that really means is 10 choose 3. And again, we can use our equation from above to get 10 factorial over 10 minus 3 factorial times 3 factorial. And if we simplify that, again, you can kind of write this out. I'm going to do it a little bit short. So 8 times 9 times 10 over 3 times 2. The first 7 factors of 10 factorial cancel out with 7 factorial on the bottom. And then we can simplify that. So we end up getting 120. Seven choose 0. So this will end up equaling 1. So if you ever have anything choose 0, that's always going to be equal to 1, because we get 7 factorial over 7 minus 0 factorial over 0 factorial. Okay, and remember, when we first went over factorials, one of the rules we need to know is just that 0 factorial is actually 1. So we just get 7 factorial over 7 factorial, which again is just 1. On the other end, 8 choose 8. So if you have anything choose itself, that will also be equal to 1. Again, because we get 8 factorial over 8 minus 8 factorial times 8 factorial, which is really just 8 factorial over 8 factorial, which is just 1. All right, so questions over any of those examples? All right, so I'll actually stop there because the next part is a little bit more difficult. And right now I just want you to be able to do this, okay? So your homework, it should be showing up right now, is a worksheet in On Campus, but I only want you to do the first half, okay? And I'll change the due date, but I do want you, well, I'm going to keep the due date the same. I want you to do the first half by next class. Okay, so you should be able to turn it in. We can look at it a little bit. We can go over questions, and then we'll cover the second half next class. All right. So I'll leave this open for a couple minutes. If you guys have questions over this stuff, you can ask. Otherwise, I will be in Teams after I end it. Yes, the worksheet with only 7 questions. You can do the first combination stuff. So everything that looks like what we just did, that's your homework. So how do I move it to Word to work on it? Here's what I suggest you doing. Download it as a PDF, and then you can do it on your laptop as a PDF. Save that, and then submit that. So I would rather not have like Word documents and stuff. Do it as a PDF on your laptop, and then submit that. All right, so I will close this. Okay, but can I write on a, yes, you can write on a PDF. You just got to be in the notes section. So I'm going to close this, and then I will open up a Teams meeting. And if you have specific questions, we can kind of talk there. Could we print it out and submit a picture? Yes, so long as I can see everything on the picture. I don't think this class I've had problems with that, but in other classes I've had. So just make sure I can actually read all of the stuff on the picture. All right, so I'll close this. I'll start a Teams meeting. And again, if you have more specific questions, we can go over it there.